Welcome to Lesson 4.1. The essential question in this lesson is how can patterns help you place the decimal point in a product? Now we've done patterns before with whole numbers. For example here, if I had this pattern that I was following, 12 times 1 I know equals 12. 12 times 10 is the same thing as 12 times 1, and then you add the 0 from the 10. And then 12 times 100 would equal 1,200. Because 12 times 1 is 12, and then the 2 zeros get added to your answer, and you get 1,200. But now today we're going to look at how patterns can help you with decimals in finding the product. Let's take a look at some examples here. So now if I was solving these equations here, following my patterns, I see I have 1 times 7,500. Well, 1 times 7,500. We know 1 times any number is going to give us that number as a result. So 1 times 7,500 is going to give us a value of course, 7,500. Now, the rule that we follow is if we take a decimal and multiply it by a power of 10, that decimal is going to be moving to the right. So here we have 7,500. We have 10 groups of 7,500s. Now what we do is if we take this 7,500 and we're multiplying it by 10, this decimal here is going to be moving to the right one place, and it's going to be right in the middle of the 7,500s, the 7 and the 5, which gives us a value of 7 5/10. So 10 groups of 7,500s equals 7 5/10. Now, if we take 100 groups of 7,500s, what we're doing is we're taking this decimal and we're moving it to the right now, 2 places. Okay, because of the 2 zeros here, we're going to take that and we're going to move it to the right 2 places, and if that decimal moves to the right 2 places, we now have 75 wholes. And if this pattern continues, if we take 1,000 groups of 7,500s, that means that decimal place is going to move to the right 3 places. So I take 1, 2, 3 places here, and I have to fill this empty space here with a 0. The decimal goes right here, and now my answer would be 750 wholes. So here's another example. We're going to follow our same pattern. If we have 1 times 3 in 1900s, that means we have one group of 3 in 1900s. So 1 times 3 in 1900s is going to equal 3 in 1900s. Now if we take 10 groups of 3 in 1900s, the rule that we follow is we're multiplying it times 10, therefore that decimal is going to move to the right one place since we're multiplying it by 10. So now the decimal is now in between the 1 and the 9, so I have 31, I have a decimal, and now I have a 9, which gives me a value of 31 9/10. So 10 groups of 3 in 1900s is going to equal 31 9/10. Now I have 100 groups of 3 in 1900s. Since I'm multiplying it by 100, the decimal is going to move to the right 2 places. Therefore, the decimal will now wind up being after the 9, and I will get a value of 319. Finally, I'm multiplying my decimal by 1,000. If I'm multiplying it by 1,000, that means it's going to move to the right 3 places. It's going to be right here. I have this empty spot I need to fill in with a 0, and now it gives me a value of 3,190. And you could put that decimal 0 in there if you like. Otherwise, you could leave it off. It doesn't change the value. So that's the rule. When we multiply by a power of 10, that decimal is going to be moving to the right. So now let's take a look at these examples, because these examples are a little different from the examples that we were looking at here. The pattern starts out the same. We have one group of 1,353. Therefore, of course, our answer would be 1,353. But now what we're doing is we're not taking a number and multiplying it by a 10 or greater. What we're doing is we're taking this 1,353 and we're multiplying it by a number that's less than 1. What this says here is we need to find 1/10 of 1,353. When we find 1/10 of 1,353, what we do is we take the decimal that's after the 3 in 1,353, and we take that and we move it back one place to find 1/10 of it, because the equivalent is taking that 1,353 and dividing it by 10. That's what we're doing when we're finding 1/10 of 1,353. So since the decimal's here and we're finding 1/10 of it, in order to find 1/10 of it, we take that decimal and we slide it back right there, and then what we get as our answer is we get a 1, a 3, a 5, a decimal now in between the 5 and the 3, and our value now changes to 135 and 3/10. Now, following that pattern, if our decimal is here in our whole number, and now we're finding 1/100th of 1,353, what we do is we take that decimal and we back it up 2 places, because we're finding 1/100th of that 1,353. The decimal now lies between the other 3 and 5, and we have now a value of 13 and 53/100ths. And in order to figure out what 1,000th of 1,353 is, our decimal is located here. We would back it up 3 places, 1, 2, 3, and the decimal would now be located right between the 1 and the 3, and we would get as our value 1 and 353 thousandths. When we're multiplying it by a power of 10 or greater, the decimal is moving to the right. And when a number is multiplied by powers of 10 less than 1, the decimal point's going to be moving to the left. Here's another example for you. The pattern starts out similar to what we've been doing. We have one group of 182, therefore our value is going to be 182. Now what we're doing here is we're finding 1/10 of 182, so it's going to be smaller. It's going to be smaller by 1/10, so this decimal in the whole number is really located at that spot right there. So what we do is we take 1/10, in order to find 1/10 of 182, we back that decimal up 1 place, and now it's located between the 8 and the 2, and we get as our product 18 and 2/10. The pattern continues. If we find 1/100th of 182, the decimal will be located here. If we're finding 1/100th of it, we back the decimal up 2 places, and now it's located in between the 1 and the 8, and that gives us a product of 1 and 82/100ths. Now, in order to find 1,000th of 182, we take that decimal and we now back it up 3 places. 1, 2, 3. The decimal goes right in front of the 1, and we have a product of 182 thousandths. Go ahead and try this pattern on your own, and when you finish, press pause to see if you answered it correctly. So this is what you should have got for the pattern here. You should have gotten 1 times the 5 and 1800ths would get you 5 and 1800ths. In order to figure out 10 groups of 5 and 1800ths, you would take the decimal and you would move it forward 1 space, because you're multiplying it by a power of 10 that's greater than 1, and you would get 51 and 8/10ths. If you had 100 groups of 5 and 1800ths, you would move the decimal forward 2 places, and that would give you a product of 518. And in order to figure out 1,000 groups of 5 and 1800ths, you would move the decimal forward 3 places, fill that spot in with a 0, and you would get as a value 5,180. And here's the last one here. Press pause and see if you could figure out how to solve this one. So what you should have gotten as an answer, you should have gotten 43 and 1/10 times the 1 would of course get you 43 and 1/10. Then in order to figure out 1/10 of 43 and 1/10, that decimal would back up 1 place, and you would now have a value of 4 and 31/100ths. In order to figure out 1/100th of 43 and 1/10, the decimal would now back up 2 places, which would give you a value of 431 thousandths. And then in order to figure out 1,000th of 43 and 1/10, you would take the decimal and you would back it up 1, 2, 3 places, fill that in with a 0, and you would get as your product 431 10,000ths. and that's how you use patterns to place decimals when finding a product.